everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. Today we have this integral and we're going to apply first case of Euler substitution method. Okay, we have integral of square root of x squared plus 4 times x plus square root of x squared plus 4 all over square root of x squared plus 4 minus x dx. Okay. The first case of Euler substitution method, first case, which is what we are applying in this problem. Okay, we will start by analyzing the expression with square root. We have a square root of x squared plus 4. So we have square root of x squared plus 4. Okay, now how do we apply this first case of Euler substitution? We have a quadratic expression inside the square root, so we can consider, we can suppose that the square root of a quadratic function is equal to a first degree function, whereby multiplying two functions we still get this expression. So we're going to consider that the square root of x squared plus 4 is equal to x plus a number, which we don't know in this case, a variable a or t. Okay. Now, considering that the square root of the quadratic function will produce a first degree function, but we don't know what's a, then we can now square root both sides. Why? To isolate the value of x. Okay, squaring root both sides, we're going to have x squared plus 4 equal. Here will be x squared plus 2ax plus a squared. Okay, now we see that we have x squared on the right side and x squared on the left side. We can cancel out both of them because they will be symmetric in relation the equality, because if one comes here will be negative, so we can cancel them. And then to isolate x, we're going to have 2ax will be equal to a squared. In this case, we just start by 4 minus a squared because this was sent that side. And x is equal to 4 minus a squared all over 2a, because 2a is multiplying comes this side dividing. Now when we isolate the value of x, what do? We differentiate to find what is the value of dx. Okay, differentiate x, we know it's going to be 1, so we're going to have here dx equal. Now to differentiate this part, we have to apply quotient rule, which is derivating the numerator. If we have u over v, its derivative is equal to u derivative times v minus u times v derivative over the denominator square. That's what we have. If we apply this principle here, what we're going to realize is like we're going to have the derivative of the numerator, it's going to be minus 2a times the denominator, which is 2a according to the formula, minus, now we keep the numerator and we derivate the denominator. The derivative of 2a is going to be only 2 over 4a squared dA, because we're derivating with respect to a. Okay, now we're going to have dx is going to be equal to, these two can multiply inside. So we're going to have minus 4a squared minus 4a squared minus 8 plus 2a squared over 4a squared, which we can reduce to a squared and minus 4, which is going to be minus 2a squared. So we're going to have minus 2a squared minus 8 dA. So that's the value of dx. But what is the value of x? If we know x is equal to this expression, that's the value of x. And the square root of this expression is x plus a. So we can take the value of x that it's only written in a on the right side and substitute here. So if we do so, we're going to have that the square root of x squared plus 4 is going to be equal to, where there is x, I will put this expression, which is 4 minus a squared over 2a plus a. And finding the common denominator, I will have 2a squared minus a, which will produce a squared plus 4 over 2a. So that means the square root of x squared plus a we can consider to be a squared plus 4 over 2a. Now, after doing that, we can simply substitute back in our integrals to see what is the new expression that we get. So in this case, we will have integral of square root of x squared plus 4. We conclude it's a squared plus 4 over 2a. So it's going to be a squared plus 4 over 2a times, now we have x. What's the value of x? Is this expression here, which is 4 minus a squared over 2a plus square root of x squared plus 4, which is this expression, a squared plus 4 over 2a over, if we check, we have again square root of this expression, so it will be a squared plus 4 over 2a minus x, the value of x, we know it's 4 minus a squared over 2a times, we have dx, and the value of dx, we found it's this expression here, so which is minus 2a squared minus 8 over 4a squared dA. This looks like a strange integral, but it's not strange and it's not difficult. If we check, we have 2a as the denominator of each fraction. So the rules for fraction, when they are adding one another, if the denominators are the same, we just keep one denominator, the same denominator, and we effectuate, we add the numerators. Okay, so we have 2a for both of them, so we will just add the numerators. So if we add the numerator, we realize that minus a squared plus a squared, they will be cancelled out, and 4 plus 4 will produce 8. So that means all this expression can be reduced by 8 over 2a. So we can reduce all this expression by 8 over 2a. So we can have here 8 over 2a. Okay, we can reduce all this by 8 over 2a. The same happen here. This negative can multiply the numerator and the base are the same. So what we'll realize, the negative when it comes in the 4 will become negative, 4 and 4 will cancel, and the negative with negative will become positive, so a squared won't be cancelled. It will be 2a squared, only the 4. So in this case, we will have 2a squared over 2a. So we're going to have 2a squared over 2a. Now if we check, 2a squared over 2a is simply a, because 2 and 2 are cancelled. A squared over a, it's just a. So here, the denominator will just be a. Okay, the denominator will be a. Now what about here? We can factorize minus 2. If we factorize minus 2 here, we're going to have here plus 4. We can just close here. Can take the brackets, because if I multiply, goes back to minus 2a squared and minus 8. And this 2 and this 4, they can cancel out and will become minus 1 over 2, which can come outside. So we can take it out. We can take it out as minus 1 over 2. We have this expression. And this we can simplify. It's going to be 4. It's going to be 4 over a, because these 2 simplifies. We're just simplifying, we're just reducing. Okay, now we have this expression multiplying this expression, so which is going to be equal as minus 1 over 2 integral, in this case, of, if we multiply, we're going to have 4 times a squared plus 4 over 2a over 2a squared, in this case, over 2a squared. And since all this is dividing a, we multiply by the inverse of the denominator. According to the maths, when we dividing two fractions, we multiply the first one by the inverse of the second one, times this expression here, times we have a squared plus 4 over, we have a squared dA. Okay, now this is going to be equal minus 1 over 2. If we multiply, this 4 can come outside, so we're going to have 4 here, and this 2 comes out as well, so it's going to be 2 times, so we're going to have 2 times 2, which is 4. With that 4, it cancels, so simply minus 1 left. So we're going to have a squared plus 4 squared all over 1, 3, 5, a to the power 5 dA, which is simply equal. We can expand this expression, which will be minus, and a to the power 4 plus 2 a squared times our b, in this case is 4, plus 16 over a to the power 5 dA. Okay, now we're going to have, this will be equal to negative, what is the integral now in this case? We can separate each one with its denominator. So we will have 1 over a plus 2 times 4. 2 times 4, it's going to be 8. So we're going to have 8 times, we know that a over 8 to the power 5 is a3. But if we take it up, it's going to be a to the power minus 3 plus 16 times a to the power minus 5 dA. So which implies that the integral of 1 over a, we know that it's ln, so we're going to have ln a. And here it will be plus 8 times, if we add plus 1, it will be 8 to the power minus 2 over minus 2 plus 16 a to the power minus 4 over minus 4. Now, we can simplify this 8 and the 2 will be minus 4 here. And we can simplify 16 and the 4 will be minus 4 here. We can simplify. Okay, but our problem was not given in which respects to a, was given in which respects to x. So if we isolate a here from the beginning where we laid, so this expression x will come subtract this side. So this means that we're going to have a minus ln, let me just put right brackets, ln of square root of x squared plus 4 minus x, here can it be minus 4 over square root of x squared plus 4 minus x. That's what we have, but it's squared minus 4 over square root of x squared plus 4 minus x all to the power 4, all that plus c. Okay, now if we check, this negative can come inside to multiply, it's not a problem. So this is how we apply our Euler substitution for the first case. Okay, thank you for watching. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.